Okay, now we'll look at the area of a square. So this is probably the most easiest one. Probably already most of you know how to do this one. If you're given a square, all sides are equal, isn't it? So if this is A, this must also be A. So the length and width are the same. Then we apply the same method as we do with the rectangle. We do width times length, or length times width. So in this case, it's just A times A, which is just A squared. So you just have to, as long as you know one of the sides, you just simply need to square it. Okay, multiply it by itself. So let's try the questions. Starting with 11, find the area of this square. It's given these little lines here, guys. If you don't already know, these mean that all sides are equal. So if this is 7, this is also 7. So the sides are 7, so we need to do 7 times 7, which is length times width, which is simply 49. Okay, so very, very simple. Now 12, okay, this time we want to find x, which is one of the sides. Now again, it's a square, so all sides are equal, and they give you the area. How do we find the area? We simply have to do x times x, which is x squared, isn't it? And that is equal to 36. So what squared is 36? It must be just 6. Now guys, remember from our algebra, you should know that if you're given x squared is 36 in an exam, what is the answer? What is x? Is it just 6? I hope most of you can tell me it's not going to be just 6. It should be plus or minus 6, right? Because negative 6 squared is also positive 36. But you should also know that in this case, we're talking about sides, length of sides. Length of sides must be positive, so that's why we only take the positive one. But guys, please take in mind that this is the background behind it, okay? So don't forget this stuff. 13, find the area. Okay, this time we're not given any sides of the square. Instead, we're given a diagonal. They give us a diagonal which is root 32 meters. Hopefully everyone can tell me what to do here. Can we use Pythagoras theorem? Yes, we can, because you can see this is a right angle triangle. I don't know, this side you can call it any pronumeral you like, s or x or whatever you like. This pronumeral is equal to this pronumeral because it's both the sides of a square. So I'm going to simply use Pythagoras theorem and let this be x, okay, because I use x. So it's going to be x squared, and this is also x, so plus x squared equals to root 32 squared, just our usual Pythagoras. Now simplify, what's x squared plus x squared? 2x squared. And root 32 squared, remember the root and the square cancels itself out, so it's just 32 left. 2 and 32 are both divisible by 2, so I'm going to divide both of them by 2, so I have x squared equals 2, just 16, okay? In this case, the reason why I didn't say x is 4, you could say x is 4 and then do 4 squared to get 16, but we all know that the area of a square is length times width, which is just x times x, so x squared. Now see how during this working out, when I've applied my Pythagoras theorem, I've already got x squared equals to 16, so I don't have to go anymore. I can just stop there and say, well, I've got x squared there, so therefore the area is just 16 meters squared. 14, find the area. Now they give you the perimeter is 24 centimeters, so they don't give you the length of the side. Instead, they give you the perimeter. So now, again, if I let the side be x, all sides must be x, right? So if I'm talking about perimeter, how many x's do we have? 4. So to get the perimeter, we simply need to do 4 times x, which is the 24. And then divide both sides by 4, so I have x is 6. Yeah, because 24 divided by 4 is 6. Now we need to find the area. That's what the question is, isn't it? So we just do our usual thing to find the square, 6 squared. So x squared, which is 6 squared. That is 36 centimeters squared. Okay, now we're getting a little bit more unique. The shapes are looking a little bit different, isn't it? It's not going to be just a plain square. You can see in this one, you could have alternative method. There's different ways of doing this question. You could divide the shape up and then find the area of 2 rectangles. But because I want to talk about more and specifically on squares, let's try using squares. So what I mean is I'm going to imagine that there are, sorry, it's very quickly, I'm not good at drawing straight lines, but if I put in those dotted lines, you can see this is a big square, isn't it? The reason why it's a square is because see how these lines are given, that is equal to that, so it must be a square. So this is also 8. Yeah, so it's a square where sides are 8. See how this shape itself is also going to be a square? And how do I know that? Because see how these two lines? Okay, because if I put one line, that means that is the same as that, but that doesn't make sense, right? So I'm going to use two lines this time. So this side must be equal to this side. That's what they give us. So therefore, length and width are the same. That's also a square. So now, what I'm going to do to find the area of the big square and then subtract the little square, because that space is hollow, isn't it? That's what I'm going to do. Before we do that, we need to find the length of this side. How do we do that? Well, see how this is given that it's 8 and this little length is 5, so that little length must be 8 minus 5, which is 3. So that must also be 3, right? Very simple to find. So let's find the area. We simply do 8 times 8 minus 3 times 3, which is just 8 squared minus 3 squared, isn't it? Just calculate that, guys. It should be 55, okay? Calculation I don't worry too much about. Now we need to find x, correcting to 1dp if the area is 640 centimeters squared. So this time we don't have to look for the area because they give you the area, but we want to find x this time. Now this time I want to try the same method as what we did in the previous question. I'm going to add in my dotted lines, try to make it straight this time. Trying to fill in those so I can make a big square. Can you see that? If I put in those dotted lines, it's a big square. So if I find the area of the big square and subtract these little hollow spaces that are also squares, I would get the area of the figure, right? And you can see that because it gives you these lines that these are equal and their length are x. So they're also squares with side lengths of x. What I need to do though is I need to find the lengths of this side, right? You can see that this is 4x, so this is 4x, this is 4x, and this is 4x. And I know that these little lengths are x. So these side lengths are going to be 6x, because it's 4x plus x, isn't it? 4x plus x, which gives 6x. The side length of the big square is going to be 6x. So what I'm going to do is go 6x times 6x, that's my big square, and subtract away. Remember, these little squares are x and x. Those are the side lengths. So the area would be x squared. But see how we have 4 of them? So I'm going to subtract away 4 times x squared. And we know that that should equal to 640 because they give us the area. So let's simplify those, guys. What's 6x times 6x? That's 36x squared. And then 36x squared minus 4x squared. See how these are like terms? So you can simplify them to 32x squared, right? And then let's divide both sides by 32. 640 divided by 32 is 20. So now I have x squared by itself. So to get x, we simply need to square root it. But I want to correct it to 1 decimal place. So stop it, put that in your calculator and see what you get. You should get something like this. And then to 1 decimal place, it's 4.5. So x is 4.5 approximately. Let's do another one. Find the area. So this time it looks like 2 squares overlapping each other, isn't it? So what I'm going to do is find the area of the big square and find the area of the little square, and I should subtract away this little square. That's also a little square, isn't it? So I want to subtract that away, and then because that's the overlapping part. So we know that the side length of this big square is 8. And we know that the side length of the little square here is 3. And they give you that this little length is 1. Yeah? So this length must be 3 minus 1, which is 2. So that's the side length of 2 as well. So this is a little square that has side length of 2. That's what we're going to be subtracting away, okay? So let's try doing that. I'm going to do 8 times 8 for my big square. Add on my little square, 3 by 3, and then subtract away my overlapping square, which is 2 by 2. That's what I'm going to be doing. Guys, just calculate that. I'm going to get you to do that yourself and check your answer. Should be 69 meters squared. Okay, so it's nothing fancy that I did. It's very, very logical. So you can see that because that's overlapping, just subtract that away. But it's easy to find because most of the information is given to us. Okay, so that was some squares.